Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of What to Look For in the Night Sky. April 22nd, 2024. We're talking about right now plowing our way through spring. So we got a lot. We got a lot of interesting stuff to talk about. I'm going to go out on a limb. I'm going to say this is the best one of these we've ever done. How many we've done now? 80? And this is the best one. We got so much stuff to cover. Here I am wasting time instead of getting into it. Let's go, let's go, let's go. The moon, right? Every now and then we have to deal with the moon, and we have to deal with the moon a lot this week. It starts the week on the evening of the 22nd in the morning of the 23rd, very near full. It's not quite there yet. It's still waxing toward full, but it's 98, 99% full. And so, very full moon. And the full moon rises. So let's talk about this just a little bit. The full moon is opposite the sun in the sky. That's what makes it full, is we see the fully illuminated face. Us, sun, moon. And so the moon is opposite the sun in the sky. That means it's up. It rises right around sunset and sets right around sunrise, up in the sky all night where you can see it. But another interesting fact to think about, the full moon, so we think the tilt of the Earth right now, if this is the sun over here, for those of us in the northern hemisphere, we're getting our tilt more and more directed toward the sun. As we do that, the equator drops below the projection of the equator on the sky. The celestial equator drops below the position of the sun. That is to say, the sun appears to get higher in the sky. We know that in the summertime, right? The sun gets higher in the sky because we're tilted toward it and our equator is pointed down below it. As of right now, the sun, we're working our way from the equinox toward the solstice, and the sun is probably, we're not quite halfway there yet. Sun's maybe 10 degrees above. It'll get 23.5 degrees, so 10 or 11 degrees above that equator right now. But what that means is the projection, the moon has to be opposite in the sky, so the moon has to be below the equator. The moon has to appear a little further in the south. It's going to be 11 degrees below the celestial equator. And so it's going to look a little further south. As the sun gets further and further north in the sky, the full moon, that's the only one that's opposite the sun in the sky, is going to look a little bit further and further south in the sky. And right now, that full moon, it starts this week. It starts right next, it grazes Spica. Spica is the bright star in the base of the Y of Virgo. You can go back to last week's video and see what we talked about Virgo right there. So you've got the moon right there next to it, within a degree or so. Just right on top of Spica. Beautiful bright star, beautiful full moon. And Spica's a little bit south in the sky, about 11 degrees below the celestial equator, and that's because it's like it's now full moon's the only one that does that. As the moon orbits around, it gets around here to noon, it's going to have the same position as the sun in the sky. And so the full moon is the only one that's opposite this way, but it's something for you to watch. Over the next couple of months, the next couple of full moon cycles, the sun's getting higher and higher and higher in the sky. That means the full moon's going to get lower and lower and lower in the sky. We'll watch for that. We'll try to remember to bring that back, but I forget. So many interesting things. A whole sky full of interesting things to think about, talk about. How can I remember from one week to the next? As the week wears on, the moon moves over into Scorpius. By the evening of the 25th into the morning of the 26th, the moon is going to be still 95% full. Now, it's past full and waning away, but it's still mostly full, and it's sitting between Antares, the big bright orange star, and these 3 or 4 stars that mark the head of Scorpius. And it'll be a nice sight to see, still up most of the night at that point. I'll take all the way to the 28th into the 29th, the end of the week that we're talking about. The moon is still 70% full. The moon is still very big and bright, but by that time it's rising. As we get the last couple of days of the week, it's rising after midnight. So we have the first few hours of the evening unobstructed by moon glow a little bit to observe the things, and that's what this board full of is about. We're going to go talk about that. But let's take a moment here to pause. We thought about this geometry. Another thing to think about, if we plot time on this axis and the fullness of the moon. So this is a new moon, and this is a full moon up here. It has a shape something like this, something like a sine curve, okay? It's not exactly, but something like a sine curve, very close. And sine curves, or sine-like curves, have these regions near the peaks where they change slowly. You see how it goes from here to here. It's changing very slowly, and from here to here it's changing very slowly. So we like to think of that as the fast part of a sine curve, and that is a slow part of a sine curve. And the full moon and the new moon are on these slow parts of the sine curve. And that's why this whole week feels like it's moon obstructed, right? It starts near full, and it stays there for so long and washing out the sky and all the stuff we want to see. And it takes the entire week for it to get down to 75% full still here. And so that's because we're going like way up here where things don't change very much. Now next week things will be changing rapidly. Zoom. We've dropped onto this fast part of the sine curve. When we get to the new moon, fortunately, it moves slowly again. And so we have good dark skies for a whole week there around the new moon where we can really see stuff. So we'll watch for that to come. So when we think about a pace of changes and sine-like curves like this week, this gives us a chance to do that as we're annoyed, right? We're sitting around thinking about, oh, so much moon, washing out the stuff we want to see. Now, in the morning sky, we talked about this the last couple of weeks. Saturn and Mars are climbing into the morning sky. About 12 degrees separates them. They rise right now something like an hour to an hour and a half before the sun comes up. So especially later in the week, they'll be separating a little bit more. You get out sometime around 5 a.m. local time. That depends a little bit on where you are. But sometime around 5 a.m. local time, you should see these two dots of light. Saturn's the higher in the sky. Mars is the redder and lower. Saturn looks yellow. Mars looks red. They'll be among the brightest objects in that region of the sky, climbing up into the sky before the sunrise. Now, we get late in the week. So we got the moon, we got the planets. We get late in the week where the moon's waning away, where it's down to this 75% full, rising after midnight. You got a couple hours. Go outside at 9:30, let's say, and look to see what you can see. So at 9:30, the moon hasn't come up late in the week to annoy us, and we've got three very bright stars. As we look to the south-southwest, we've got three stars that are brighter than the rest. Regulus, the base star in the sickle of Leo, is a big bright star up here. Procyon, at 9:30, Sirius will have just set, and so that leaves Procyon as the brightest object in this part of the sky over here. And we've got Alphard and Hydra down here, and they form a sort of right triangle up this direction. Now, at the top of this gives us a chance to try to study the stars of Hydra. We don't see Hydra very much. There's a lot of interesting faint stars, right? A lot of stars that are on the threshold. If we can see down, remember the magnitude system counts backwards, so 1 is brighter than 2 is brighter than 3, and it's a factor of 2.5 in apparent brightness with each step on the magnitude scale. So a sixth magnitude star is 5 steps fainter than a first magnitude star, and 2.5 to the 5th power is 100. So a 6th magnitude star is 100 times fainter than a first magnitude star. All of these stars are sort of around 4th magnitude, bubbling up slightly to be close to 3rd magnitude in a couple of cases down here that we'll talk about. So 3rd to 4th to 4.5 magnitude. You got good dark skies. I'm going to say you can see down to about 5th magnitude is what you can see down to. So these are stars right up. You want good dark skies. You can't let the moon come up and wash this out. But you can see the head of Hydra, this little knot of stars, sort of halfway between Regulus and Procyon. And their delta is 4.1 magnitude. Move over to the top of this sort of quadrilateral. Epsilon is 3.4 magnitude. Eta is 4.3 magnitude. And sigma is 4.5 magnitude. At 30 degrees is Procyon to Alphard. About 23 degrees is Alphard to Regulus across here, okay? What your fist at arm's length, remember, is about 10 degrees. So about 3 fist widths across here and about 2 up this direction. Halfway between there, we've got this grouping of this quadrilateral of stars. Now, right next to Epsilon, the 3.4 magnitude star in the upper left of this quadrilateral, right next to it is Rho at 4.3 magnitude. These are all Hydra stars. Rho Hydra, Epsilon Hydra, Delta Hydra. And then Zeta is the brightest in that group at about 3.9 magnitude, just off to the west of that group. Drop down 6 degrees to Theta, and you've got, so half a fist width down to Theta, you got a 3.9 magnitude star. And then you've got a pair of stars that make Tau, about 4.6 magnitude, and Iota is just to the west of Tau at 3.9 magnitude, another 6 degrees or so. So a full width, just over a full fist width down from this grouping up here to Tau, and then you drop down to Alphard. 11 degrees, just over a full fist width, or about a full fist width down from Alphard to Lambda, and then on down another fist width to Nu. at 3.1 magnitude and 3.6 magnitude. So these stars are a little bit brighter than these other stars as you move west of Alphard. And these stars, interesting with Hydra. We'll try to remember to talk about this later in the next couple of weeks too. Hydra just kind of ends. It runs into Crater and it runs into Corvus, and then it starts up again on the other side. And so we can think about Hydra coming on over here. But for now, let's go as we go from Lambda down to Nu, about 5 or 6 degrees, drop below that line and angle back toward Lambda. You come to a 3.8 magnitude star, another good 4th magnitude star. A lot of these in Hydra. And you come to Mu there, and so you'll see a star that's below that line a little bit right in there. Just below Mu, about 2 degrees, a little less than 2 degrees, so a little over finger width below Mu is NGC 3242. And NGC 3242 is a fairly bright but small planetary nebula. That's the case with planetary nebulae. They tend to be bright-ish but small. And so they're hard to see. A little bit of magnification in a telescope goes a long ways to helping you see that. And this one, it's hard to, when you have a high magnification in a telescope, it's hard to find something because the field of view is so small. You've got to really be good at pointing unless you've got a point and shoot scope that goes where you want it to go. But this one, because it's so close to Mu, if you can find Mu Hydra, you can just drop straight south from there, just go slowly down with a high power eyepiece in your telescope, and you'll run across this glowing disk, a bluish disk, a greenish disk, of light, and that's this outer layer. What a planetary nebula is, nothing to do with a planet. What a planetary nebula is, it's a star, a low-mass star like the Sun, that has reached the end of its life, and it has sloughed off its outer layer. So you've got gas, you've got its outer shells. It's being puffed off out into space, and so you see the envelope of the star expanding into space like this, and that's a gas cloud that you see. But it hasn't. Once it expands very far, then it gets so thin you can't really see it very much. So you have to see these when they're relatively young, and so they're small. They're just, they're still small. They're not that much bigger than the star, maybe, but they're dense enough to be bright enough to see here. So that's what you've got going on here. At the core of that is a white dwarf star. My recollection is the white dwarf star at the core of this planetary nebula is about 11th magnitude, which is within reach. If you got a 6 or 8 inch telescope, you can see the white dwarf star, the core of that star that's left over there just to cool away as this outer layer puffs up. Lots of low-mass stars in the sky. They all want to end their existence this way unless they're part of a binary system and some magic happens, but that's a different story. And so lots and lots of planetary nebulae, lots of stars are going to become planetary nebulae. And NGC 3242 is a pretty good example to see if you can find it in Hydra this week. Got to do it late in the week. You can't let the moon. You can't let the moon be nearby and in the sky glowing and blowing this thing up. Man, what a week. What a week. We got learn the stars of Hydra. Just go out and learn the stars of Hydra. Hydra's a very few people. You go out to parties and talk to friends at parties and try to understand who has Hydra as one of their favorite constellations. Who even knows it is a constellation? Who knows where it is in the sky? Who knows what any of the stars look like? So find these stars and learn these stars. Enjoy that triangle of Procyon, Regulus, and Alphard. And think about the moon. Think about where the moon is in the sky, in the orbit of the sun. Watch for the planets in the morning sky. And you got a great week ahead, everybody. As always, thanks for watching, and we'll have something new for you next week.